So the Deepseek Reasoner API or the Deepseek API itself is not available since few days. If you go to deepseek.com and try to uh, click API access, it will say that the site is down for maintenance. So I was thinking, how do I test this reasoner model? How do I test it with some prompts? So what I did is I used Olama to download a local version of it and then execute the reasoner model. In this recording, I wanted to show you how I did it. So first of all, I went to olama.com. I already earlier downloaded Olama, but you'll have to download it once you click on it based on your system, whether it's a Mac OS or a Windows. It will download Olama, install it. After installing it, you need to find the model that you want to run. So Deepseek R1 is now available in Olama, and I downloaded 8B. What I did is Olama pull Deepseek R1 8B, right? This is the command that I ran after installing Olama. Now, when I pull these models, the Olama provides or it hosts that model in local host in this port 11434. So after I installed Olama, after I did a Olama pull the model name like this, I wrote this code. So first of all, so I wanted to create a client, Deepseek client, and then use the client. So I created a class called Deepseek client. In my init method of the Deepseek client, gave the URL. This is the URL and the model name, which is Deepseek R18B, right? And then in the same class, I created a generate function, which takes prompt as one parameter and stream as another parameter. By default, stream is false. Then I have the payload, which is a model, the name of the model, the prompt that I'll pass while calling the API, and this streaming method. Then I call the request function from Python request.post. I provide the URL, which is this URL here. Then the header is application, like the content type is application JSON. And this is my payload. This is the payload, right? And I return the response.json, right? This two, so the init function and the generate function, I encapsulate it in the Deepseek client. And then I created a Deepseek listener agent where I return the agent. The return agent is the function in the Deepseek regional agent class, where it creates a client that instantiate the client, the Deepseek client here, right? And then just returns the Deepseek agent, right? Then in my main method, I uh, get a get the Deepseek agent by creating or instantiating the Deepseek reasoner agent and calling the return agent for the Deepseek agent instantiated from the Deepseek reasoner agent class. The prompt I give is 9.11 and 9.8, which is greater. And then on the agent, since I get the Deepseek agent, which is nothing but the client, and on the client, I have the generate function. I do a dot generate and the prompt, and I print the prompt. So let me run this and see how it looks like. Since it is running on my local, it will take some time. and I am using 8B, 8 billion parameter one. There are other parameters, 14 billion, 32 billion, 70 billion, 671 billion, but I'm running the 8 billion parameter. Right? So let's see what response it gives me. Um, After this, okay, while it is running, I wanted to try one more prompt using a publicly available data set from Simple Bench. Simple Bench, it's used to um, benchmark the reasoner models. This is a dataset that is used with some of the prompts like this, right? So I took this. Let me actually show that prompt. We'll run this prompt after this and see how it uh, responds to this. So the prompt is: Beth places 4 whole ice cubes in a frying pan at the start of the first minute, then 5 at the start of the second minute, and some more at the start of the third minute, but none in the fourth minute. If the average number of ice cubes per minute placed in the pan while it was frying a crispy egg was 5, how many whole ice cubes can be found in the pan at the end of the third minute? The answer for this should be 0 because, since it's a frying pan, the ice will melt, right? But as I expected, this language models how much reasoning it does, right? It is not like us humans who have gone through the 5 stages of intelligence. And one of the stages simulation, right? Where we simulate and we are able to uh, mentalize things. We are able to, or based on the world patterns, we know or we can simulate what might happen in a certain situation, in a certain scenario. In this scenario, a human will, based on the pattern we have uh, stored in our brain, in our memory, of a frying pan, of ice, how they interact when the ice falls on a frying pan, else probably answered 0. But when I give this to Deepseek, it actually gave an answer of 20. I ran it once and this was a response. We'll run it again and see what it does. But in the meantime, let's see if it completed the other one. Right, I'll just copy it now. Yeah, it completed the other one. So for this, the prompt was 9.11, 9.8, which is greater. So see in the paper, you will see that this have trained it to give the thought process within the think tags. So within the think tags, you can see it has given the answer to determine which number is greater between 9.1 and 9.8. I'll first align the decimal places by writing 9.8. It's 9.80. Next, I'll compare the numbers digit by digit. Both numbers have same integer part of 9. So I move to the 10th place. In the 10th place, 0.1 is 9.11 is less than 0.8 in 9.80. This means that 9.11 has a smaller value than 9.80 at this stage. Therefore, after comparing each corresponding digit and considering their place values, I can conclude that 9.8 is greater than 9.11. Uh, so, so this came in the think tag, but after that, it again was adding more thoughts. This part, I'm was not very sure like why it again um, started thinking, but the answer was it gave is right, right? So this one it answered correctly. Now let me give the other prompt and see what it answers. So as we see, already saw, this one was like where we place ice cubes on a frying pan. At the fourth minute, we want to know uh, how many ice cubes are there in the frying pan. Let's look at the question again. It is from the simple bench. This is the question. Beth places 4 whole ice cubes in a frying pan at the start of the first minute, then 5 at the start of the second minute, and some more at the start of the third minute, but none in the fourth minute. If the average number of ice cubes per minute placed in the pan while it was frying a crispy egg was 5, how many whole ice cubes can be found in the pan at the end of the third minute, right? So let us run with this prompt. Now, while it is running, let me go through the response that I got earlier with the same prompt, right? So this was the response earlier. First, I'll summarize the information provided. At the start of first minute, Beth places 4 ice cubes. At the start of the second minute, she adds 5 more ice cubes. At the start of the third minute, she adds an additional number of ice cube. Let's denote this as X. No ice cubes are added at the start of the fourth minute. The average number of ice cubes placed per minute is 5. This means that over the 4 minutes, a total of 4 times 5 equal to 20 ice cubes are placed in the pan. So far, we have first minute 4, second minute 5, third minute X. Adding this together, 4 plus 5 plus X equal to 19. To find X, subtract from the total. 19 minus 4 plus 5 equal to 10. So Beth placed 10 ice cubes at the start of the third minute. To determine the number of ice cubes in the pan at the end of the third minute, for 4 first minute, 5 at the second minute, X plus 1 equal to 11. Since each, so not sure why, how it used this information. Adding this up, 4 plus 5 plus 11 equal to 20. Finally, at the start of the fourth minute, no ice cubes are added. Since no time passes during this minute, the total number of ice cubes remains 20. So this comes with a think tag, then it's again starts analyzing the problem step by step. But the final answer was also 20, right? So it the ideal the answer, if it actually had intelligence built, it would have answered it 0. Now the question arises, the definition of intelligence now, right? So is thought and language enough to build intelligence, or do we need a world reference? The reason as a human I am able to say that there will be only 0 ice cubes on the frying pan, because I have the world model in me. Since I was born, through reinforcement learning, through different augmented learning as well, I built a model of the world. And based on that model, I'm able to put reasoning, I'm able to put logic and then answer a question. The question therefore is, are these reasoning models lacking that reference world model? I am doing more research on this space, and as I find more things, I'll share. I'll bring through my learnings through this recordings. For today, that's all. By the time it ran it again, but here also, wow, this time it says 0. Let's read it. First, I'll note down the information provided. 4 ice cubes placed, 5 ice cubes placed, some number of ice cubes placed, no ice cubes placed. The average number of ice cubes per minute is given as 5. Since the frying process lasted for 4 minutes, the total number of ice cubes placed is 20. Setting up the equation based on the information provided. Then it says, okay, it is solving for X. So at the start of the third minute, Beth placed 11 ice cubes. To find out how many ice cubes are in the pan at the end of the third minute, I need to consider both the placement and the melting. This time, it is actually, and this is what, uh, I'm not say concerned, this is what confuses me. Why the first time when I ran, it thought in a certain way, but the next time, the same model, it is now able to apply the concept of melting. Assuming each minute all ice cubes melt except for those added in that minute, we can calculate the remaining ice cubes as follows, right? So, uh, since the pen cannot have a negative number of ice cubes, we can infer that by the end of the third minute, all ice cubes would have melted, right? So here it is able to apply the concept of melting, and this is when I ran it for the second time. But when I ran for the first time, it was not able to get the concept of melting, right? So there is still some gap. For human, it probably will never happen in this scenario where in my world model, I already know that when heat and ice comes together, it melts. So for me, the concept of melting would remain the same how many number of times I'm given this question. So this still remains a mystery for me, uh, and um, I need to do some more digging to find out why it thought in one direction in the first time, but in a different direction second time, where it actually thought in the right direction by applying the melting concept. That's all for this recording. Um, the main thing here for me was to show how to run the Deepseek reasoning model locally. On the reasoning part, I'm doing more research and come back with more as I find more. Thank you.